All right, we are on the calculator part of the review. It's pretty short. There's not a lot of calculator part on this test. So this goes back to, remember, we had a quadratics quiz in this chapter. So you have 100 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Remember to consider domain of x if you're trying to figure out how to graph this. All right, so we have 100 yards of fencing. We are enclosing a rectangular area. Let's call it x and y as the dimensions. So 2x plus 2y would equal 100. So you should always have a perimeter equation. And we're trying to find a maximum area. So the area in general of this rectangle would be x times y. Now, we don't want to have two variables in this equation on the input side, so we need to solve the fencing equation for either x or y. It doesn't matter. Oops, I'm going to solve it for x. So isolate the 2y, divide by 2, 50 minus x. So the reason we do this is because now we can sub this into the area equation. So now it's a function of x. Area is equal to x times 50 minus x. Now you can leave this as it is, or you can distribute and make it 50x minus x squared. If I'm trying to find the maximum area, and I know this is a parabola that opens down, I'm trying to find the vertex. Now, you could either get the vertex in DESMOS, or you could get the vertex algebraically. If you're going to do DESMOS, remember it might help to know the domain. So for this function, we need x to stay greater than 0, so we don't get a 0 area. We need 50 minus x to stay greater than 0, again, so we don't get a negative or a 0 area. That means that negative x needs to be greater than negative 50, x needs to be less than 50, so x needs to be between 0 and 50 to make all of this work so that we don't have a 0 area or a negative area. All right, so I'm going to show you DESMOS. Maybe. Oh. There we go. So, sorry, making sure I'm still recording. Okay, so I'm going to show you DESMOS. Here we go. So suppose I don't distribute, I just leave it as x times 50 minus x. Doesn't matter. Now, by default, I can't really see much of this. I could just zoom out, but sometimes the vertex is at like a really large number and the zooming gets kind of crazy. So I want to remind you how to zoom fit. You can always add a table. The domain goes from 0 to 50. And I want it to graph a of 0 and a of 50. Now, if I zoom fit right now, it will show me those two zeros, but again, the vertex is way up here. So the vertex is going to be halfway between these two zeros. But if you want to see it more clearly, put in a third point, which would be halfway or somewhere near the center if you can't quite figure out the center, and then zoom fit again, and there it is. But that 25 is the vertex. If you have a parabola and you know the two zeros, the vertex has to be in the exact center between them. So the vertex is 25, 625. And remember what this represents in your a of x equation. The inputs are the values for x, and the outputs are the values for area. So when this problem says, what is the max area? Max area equals 625 square yards. Remember to label. And then the dimensions are x equals 25 feet. No, not feet, yards. And y equals 25 yards. Now, when we had this quiz, some of you asked me, like, if we're just doing a rectangle, can't I just say a square will always have the largest area? And yes, you can. So you could have also just said 100 yards of fencing divided by 4 would tell me what the sides of the square are. 100 divided by 4 is 25. Figure out the area. 25 times 25 is 625. I'm perfectly fine with that. But remember, if, like on our quiz, if we have fencing down the middle, then you can no longer make a perfect square out of this. So just be careful with that. All right, next problem. This function here with this domain models U.S. movie attendance and billions of tickets sold for years after 2000. During which year was the movie's attendance at a maximum? What was the maximum? So this should be pretty easy as long as we can get it to fit in our window. So I'm going to erase, X out what I have here. I'm going to type this in carefully so it's exactly what I see. So negative 0.03 x squared plus 0.14x plus 1.43. And we don't want to look at the entire graph. We only want 0 to 5. So I'm going to add a table. 0 to 5, f of 0, f of 5, and then zoom fit. Now, again, this is kind of like large, so I can zoom out, or I could throw in another point of like, okay, tell me, I don't know, f of 2. See if that makes it nicer. That's a little better, right? So in this interval, what is the maximum attendance? So the maximum attendance is, click near the top, right there. So I'm going to write this down, write down this ordered pair first, and then we'll translate it into our answer. So it's 2.3 repeating, 1.593 repeating. Okay, what does this represent? So during which year? So remember, this is years after 2000. So during 2002. I'm not going to round it. If this rounded up, I wouldn't round it. It's still during 2002. The max attendance, which is this, was, now I'm not going to round this to a whole number because remember, this isn't a number of people. Like it's not 1.5 people, it's 1.593 million. And I guess it's not people, it's tickets sold. Oh, no, wait, not million, billion. Tickets sold. So they're measuring attendance in how many tickets were sold. All right. And then find all the zeros in the complex number system for this graph. So if I'm not giving you zeros, then what I want you to do is graph this f of x. So again, I'm going to make sure that I type it in correctly. So f of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. I cannot see this very nicely. The window's kind of weird, so I do have to just zoom out a little bit. I don't think I would add a table for this. I'm not going to give you extreme values either, so I can see two of these right now, x equals negative 2 and positive 3. It's going to be within a plus or minus 10 window for the problems I'm giving you, so the zooming shouldn't be too crazy. So x equals negative 2 and positive 3, and this is from DESMOS, or my calculator. All right, now the rest of this is kind of without my calculator, so find all the zeros. So here are two of them. But this is degree 4, so the other two zeros are probably imaginary. So we can find them by doing 2 rounds of synthetic division in any order. I'm going to start with negative 2. I'm going to use the coefficients here. Drop down the first number, multiply, add, multiply, add, multiply, add, multiply, add. You've done it correctly if there's a 0 right there. Now this represents x to the third minus 5x squared plus 16x minus 30. We need to divide that by x minus 3. So put a 3 here, use those remaining coefficients, leave off the 0 remainder, drop down the first number, multiply, add, multiply, add, multiply, add. This is now x squared minus 2x and a constant term. So now we have f of x fully factored out. X plus 2, x minus 3. Those are the factors from these zeros. And now I have x squared minus 2x plus 10. I can't factor this. There are no factors of 10 that add or subtract to negative 2. So if I'm looking for when this is equal to 0, I will use quadratic formula. 2 plus or minus the square root of b squared minus 4ac all over 2a. This is 4 minus 40, which is negative 36 underneath the square root. That's 2 plus or minus 6i over 2. And that is 1 plus or minus 3i. So the zeros are negative 2 and 3, also 1 plus or minus 3i.